presenting one of the projects on the contact-based Q&A bot, which we have used a few techniques, and these are our team members. Shubham Choksi, Zoya Manzoori, Mas Patel, and me, Yash Pandit. Next slide. So this is the overview of our projects, which includes introduction, methods, which dataset we have used, some of the modeling techniques, results, conclusion, and what future works can be implemented in the projects. So our project is very simple. We have used GPT's pre-trained model and squad dataset to create a state-of-the-art machine learning Q&A bot, which can easily provide any of the Q&A, I would say questions answered with more context. So furthermore, will be continued by my team members as well.
Software development methods we have used agile. In agile is the iterative process which would help us to develop our machine learning model. So first of all, in plan phase we'll collect the information for the models, like how we want to execute it. Then we design the model, develop the model, test it, then deploy it and review the model. After each and every iteration we'll be able to launch our model with the SDLC. So it helps us in the iterative development of our model. For dataset, we have used Stanford question answering squad data, which is reading comprehensive dataset and consists of questions posted by crowd workers on a set of Wikipedia articles, where the answer to every question is segment of text or span from the corresponding reading passage, or the question might be unanswerable. Here it consists of the three-column question text contains. We are having around data of around 43,000 of rows, and it contains the questions along with their text, which is answer, and it also represent the context of in the data grid. So moving further, we have cleaned the database. For the database cleaning, since it's a language data, we have first of all convert the text to the lowercase, remove punctuation, and then we tokenize the text. Now, the lemmatization is the process of reducing words to their base or root form, known as a lemma, which helps in understanding the context and meaning of words. Removing stop words involves eliminating common words such as and the and is, which typically do not contribute significant meaning to the text analysis, thereby improving processing efficiencies and focus on more meaningful words. Both techniques are essential for text processing and enhancing the performance of NLP models. So we have removed stop words and lemmatized the tokens and then join those tokens. Moving further, Subham will continue with word cloud.
So the reason to use word clouds as data visualizations is, first of all, it provides quick insights to the data set that we have. It is easy to understand, it highlights key terms, and it identifies trends that are present in the text analytics. So the visualization that you see right here, that is the visualization for the text column that we have. The text column is basically the answers that we have for our questions. And if you can figure out the word African, air, and act, you can pretty much see those. So from this, we can pretty much conclude that these words are repeating more, and thus the answers are more related to these uh, words. The next thing that we have with us, the next thing that we have with us is the questions. It's the same word cloud that we have, but the point here is that we have according, act, and addition that are being highlighted, and those are the few words that are being repeated in the questions column. The next thing that we have with us is context. I'm sorry, the modeling code snippets. The modeling code snippets, what we are doing is that we have a tokenizer that is pre-built using the GPT-2 tokenizer. The reason to use this particular tokenizer is that it would take text directly, it would tokenize them without doing any sort of pre-processing to the steps. So that is the reason why GPT-2 tokenizer should be used when we are using a GPT-2 pre-trained model. In the next step, what we have done is that these are the training arguments that you can see in the function given, and then we train our model using the collator that we have, the model, and the tokenizer. The next will be continued by Mars.
Okay, so in the results, as we can see that we have asked several questions and the model has given us precise outputs. Uh, next, so in conclusion, uh, in this project, we successfully developed an advanced Q&A bot using this GPT-2 model, focusing on accurately and contextually providing responses to user queries. By fine-tuning GPT-2 on the squad dataset, we implemented robust pre-processing techniques And we also ensure that Q&A bot's ability to handle complex text inputs and deliver precise answers. We integrated technologies like PyTorch, GPT-2 tokenizer, and GPT-2 LM head model. All these were instrumental in achieving the desired outcomes. Project results highlight that the potential of GPT-2 as a powerful tool for context-based question answering demonstrates significant improvements in response accuracy and efficiency. For future work, in context of model refinements, we can do further fine-tuning and experimentation with different architecture and also transfer learning techniques to improve GPT-2's accuracy and adaptability to various question answering tasks. For user feedback integration, we can implement feedback mechanisms where users can rate or correct the responses of the bots, and this will enable continuous learning and refinement of the model. User interface development, focusing on the development of a more intuitive and user-friendly interface will enhance user engagement and satisfaction. This will include customizing options, improving designs, and ensuring a seamless experience across different devices and platforms.
So, considering the link of the project that we have here, this is the Trello board. This is the Trello board that we have for our project here. Then this is the Google Collaboratory that we have used to code. And in this, you can see right here that these are the few steps that we have performed. For example, we have installed libraries, we have imported the libraries, performed pre-processing, then we tokenized, and then this is the training of our model. Here you can see the stepwise deduction of every single learning of every single measures that we have here. And at the end, this is the simple example where we are asking a custom question to our processor, to our model, and we are giving a little bit of context. And what the model is doing here is that if any different type of question is asked to the generator, to the model, it will give a similar answer to that. And this is what we are trying to demonstrate. Furthermore, the Trello board that we have already seen here, this is the overleaf that we have. So this is the Google slide, the Google site that we have with our collaboratory in there, the Trello board, and we'll be uploading our YouTube video shortly in here. So thank you so much.